Open. Hook plus promise. Hook. If you remember one thing about simple circuits, remember this. Same voltage means parallel. Same current means series. Today, I'll show you how to choose between them in plain English. No equations. What viewers will learn. You'll see real examples, LEDs, heaters, and sensors, and you'll learn a quick checklist to go from schematic to real-world wiring. Credit. Special thanks to Tony Coupalt and the open source community. Our lesson follows the model materials under Creative Commons. Section 1. The one-sentence rule. Voltage is a difference between 2 points. If several devices must share the same voltage, wire them in parallel. If several devices must share the same current, wire them in series. Think of voltage like water pressure and current like water flow. If you want each faucet to have the same pressure, you tee them off the same supply, parallel. If you want the same flow through everything in one line, you put them one after another, series. Section 2. Real-world examples. You'll actually use lighting and loads, most common. Multiple lights, a motor, and a heater in a small panel, or just a bunch of indicator lamps. You almost always want each device to see the same voltage from the source, so one failure doesn't dim or shut down the rest. That means parallel. Sensors that need the same current. Some sensors and test setups want a constant current through a chain, like a series string, where each element gets its share of the total voltage drop. You wire these in series because the same current flows through all of them end to end. Batteries. Batteries in series add their voltages for higher voltage. Batteries in parallel keep the same voltage but increase available current for longer runtime. Match chemistries and capacities and follow manufacturer safety rules. Section 3. How to decide in 30 seconds. Checklist. What do the devices require? If they need a specific voltage, go parallel. If they require the same current, go series. Do you want one failure to take down the others? If the answer is no, choose parallel so each device has its own path. Will you be measuring across each device? If yes, parallel keeps the reference simple because each device shares the source voltage. Is this a sensor chain or a test string? If yes, it might be series to guarantee the same current. Section 4. Measuring safely. Meters measure between 2 points. Your choice of the 0 point, often called ground, changes what the number means. A bench oscilloscope's ground clip is typically bonded to earth for safety. Clip it in the wrong place and you might create a short. We'll go deeper on safety ground versus reference ground next episode. Section 5. Quick history bit. Why power grids use parallel. Early arc lamp streetlights were often wired in series. If one lamp failed, the whole string could go out or need a bypass. Thomas Edison's incandescent systems pushed parallel distribution so each lamp got the same voltage and could work independently. That simple idea, same voltage for each load, is still how homes and factories are wired today. Section 6. Mini demo props. 1 small power supply or battery, 2 identical lamps or LEDs with proper resistors, and a multimeter. Steps. Wire the 2 lamps in parallel. Measure voltage across each lamp. You'll read nearly the same voltage as the source, and both glow normally. Rewire the 2 lamps in series. Measure the same current through both. Use a clamp meter if available, or an in-series milliamp measurement. Each lamp now shares the total voltage, and brightness changes. Call out what stayed the same, current in series, and what stayed the same, voltage in parallel. Section 7. Common mistakes you can avoid. Putting indicator lamps in series so they all go dim or black when one fails. Trying to share one series resistor for multiple LEDs in parallel. Minor differences in parts cause one LED to hog current. Use 1 resistor per LED or use a driver designed for parallel strings, assuming ground is always the dirt. In many small circuits, ground just means the reference node. We will unpack this in the grounding episode. Section 8. 10-second recap. Same voltage, parallel. Same current, series. Voltage is a between 2 points idea, and your ground choice defines those points. Next time, we'll separate safety ground from signal reference so your measurements are right and your setup stays safe. Outro, CTA. If this helped, tap like, subscribe, and share with a classmate or coworker. Drop your series or parallel questions in the comments, and we'll add them to a future troubleshooting episode. Huge thanks again to Tony Capalt and the open source community. Links are in the description.